And some of these results you already heard today from Mr. Bayenbruch, or just now from the two PhD students, and also from Mrs. Altmann about the washing machine tests. And I will now try to give a broader perspective of the results and also some of the recommendations that came out of the 20 different projects. But first of all, we have to go back a bit to where it all started. The call for proposal was published in 2016, and then the first projects could start in summer 2017. And then it took, as you can see, 5 years of research. We had a big closing event in April 2021. It was just online due to the corona pandemic, and that's why we are also very happy that we can now close the whole research focus here today with this event on EU level in the representation of the Free State of Bavaria. Just some of the relevant facts and figures. In total, it was around 40 million euro of funding for these 20 joint research projects, and we had more than 100 institutions from science, economy, and practice that were organized to do the research in these projects. We had an accompanying project named PlasticNet, which was for all the underlying organization, and they also did a great job with this event here today. The goals of these research focus were to analyze the entry routes, mobility, and effects of plastics in the environment along the whole plastic cycle, and to identify and implement some solutions for reducing the emissions of plastics in the environment. They were structures along 5 thematic areas, and you can see the focus of the different projects in these thematic areas. We also had, beside this, 7 cross-cutting working groups where the scientists from these different joint research projects come together in workshop and networking events and exchange their views on in some 7 topics that have been identified as relevant to all these 20 joint research projects. And in many cases, joint publications were a result of this exchange. We had some about the analytics and reference materials, about the effects of plastics on the environment, terms and definitions, social and political dimension, modeling and life cycle assessment, recycling and product design, and biodegradability. And the most important key messages from all these 20 joint research projects and these 7 cross-cutting working groups were summarized in these documents, the long and the short version of the key messages of the whole research focus. And overall, we can say that the research focus has contributed to the further development of scientific procedures, methods, and instruments for investigation of plastics in the environment. And the existing knowledge could be expanded, and important progress has been made in many different aspects. And I will show you now some of these relevant findings, but just in a short way. Here we are in the section where you already heard a lot about today, the area of green economy, where the goal was to examine the inputs and losses of plastics along the entire value chain, and also aimed at developing measures to reduce the plastic inputs. We heard about the tire abrasion from Mr. Bayenbruch and also from Ms. Horneck-Gausterer. And we also heard something about the textiles, where the projects came out with the results of these large amounts, especially emitted in when clothing is washed for the first time. And some recommendation that could be given was filling the washing machine to capacity, and also shortening the washing cycle could reduce the discharge. And as Ms. Altmann explained before, after a certain amount of washing cycles, then the discharge is also reduced. In the area of consumption and consumer behavior, it was the goal to investigate meaningful and effective measures for a more sustainable consumer behavior, and also to develop solution strategies and recommendations. However, low prices of single-use solutions and primary plastics, as well as the high prices for reusable products, aggravate the substitution and reduction of usage of single-use solutions. So what is needed are stronger incentives for avoidance, like subsidies, or also at some points restrictions are needed. The projects also find out that solutions that are just based on quality seals or labels have limited effects, because many products and packaging is so much overloaded with too much information that they overstrain consumers, and that leads to the effect that the consumer doesn't really behave as he is intended to do, because he has the information on the package, but he is not able to behave as it should be. So the task that political measures often focus on private consumers is not sufficient, because their scope of action is limited due to the lack of knowledge, and also when they don't have practical alternatives, it is not so easy for them to change their behavior. Also, we have products whose intended use leads to contact with or retention of microplastics in the environment, and that would be a better solution to just replace these products with products that don't have these effects. The focus in the thematic area of recycling was on the development of innovative processes to facilitate recycling and the collection of end-of-life products, and also to increase the proportion of high-quality recycling. Current sorting technologies have shortcomings in distinguishing between food and non-food packaging, single-layer and multi-layer films, and also in separating subclasses of materials. So one solution is an innovative tracer-based sorting system that was developed in one of the projects to improve the sorting and to enable a high-quality recycling. Also, chemical recycling processes can contribute to higher recycling rates, because they enable the use of complex waste streams that were only thermally processed before. And these two developed processes also have ecological advantages, which could be demonstrated. In the area of freshwater ecosystems, we know that risk assessment of microplastics requires reliable data. We just heard about this standardization process and why it is so important. And we need this data on the occurrence, on the impact, on the behavior, and possible input pathways. And these coordinated and harmonized analytical methods are a central prerequisite for the assessment of potential hazards that come with microplastics, and also for solutions to reduce these inputs. Within these research projects, significant progress was made in analyzing the microplastics. The area of sample collection, sample preparation and detection, the quantification of particle numbers and also polymer masses down to 10 micrometers in size was possible. One project also was able to extend the analytical range to particles as small as 200 nanometers. Then there was a comparative test carried out to demonstrate that both of these methods are suitable for identifying microplastics and quantifying them. And all these findings, as we just heard, are essential basis for the standardization. What about these effects of microplastics? They are not yet comprehensively documented. There could be no acute toxicity of microplastic particles found, but effects on fitness and activity in some aquatic organisms could be detected. For plastic particles smaller than 10 micrometers, no sufficient data is available at the moment. And we also heard today that microplastics can release toxic additives, and there a declaration obligation would be needed. The sources of plastics and the input pathways into the environment were always also investigated. Littering is one very significant source for localized high inputs. We have also diffuse sources like sport grounds with artificial turf, construction sites, landfills. But, as we already heard today, more than 95% of the micro and macroplastics can be removed in wastewater treatment, and with further process technology, we can increase this retention to nearly 100%. These particles accumulate in the screenings and grid taps and in the sewage sludge, and then it's the problem what we do with this. We have also indications of high emissions to soils and waters via the combined sewer overflows and the untreated precipitation water, and therefore the investigation is needed. In the area of plastics in seas and ocean, the focus was on mapping the spatial distribution and variability of microplastics from estuaries to coastal waters and into Baltic Sea and North Sea. The methods used to were developed to detect microplastics down to 10 micrometers in marine environment, and the results also transferred to a marine plastics database where they are still available. The entry pathways that were identified through hydrologic and land use models showed that agricultural uses, like the sewage sludge, have a major influence. Also, transport and accumulation within the coastal waters determined by current conditions, tides, and runoff patterns. So extreme weather events lead to growing inputs, and also remobilization of sedimented particles. We also have biofilm effects, that the light particles, when they have a biofilm, then they sink and sediment in certain areas. And accumulation areas, especially in this environment, are beaches, sediments, and harbor basins, where they also found a lot of dye particles. Now back at this subject. So, besides all these results from the different thematic areas, we have these results from the cross-cutting topics and the enhanced analytical know-how. We also have results on the ecotoxicological assessment of microplastics. We have a compendium of the terms and definitions related to plastics in the environment. We have key messages for a more sustainable society, and also a synthesis paper for the modeling of microplastics, and summarized knowledge on biodegradability, just to name a few. And another important part in this whole project context was that we also looked at the change in consumer behavior, which can make an important contribution to avoid the entries of plastics into the environment, and thus also the formation of microplastics. So for shaping the handling of plastics in a more sustainable way, information is needed to the society about the effects and what can be done against this. And we did a lot of different formats to not only inform the expert community on the results, like webinars or blog posts and fact sheets, but also a big day in Berlin where all the projects presented their results to the general public. Also, we supported a citizen science initiative called Plastic Pirates that is now also spreading across Europe. And we also did some books for kindergarten children to also inform them and hope that they bring this information to their homes. So, to end with some recommendations for action, measures to reduce plastic emissions in residential water management can only accompany strategies at production and use phase of plastic products, because it's only the end-of-pipe solution. The precautionary principle is important. Environmental policy should aim to minimize the input of plastics in the environment, since adverse effects cannot be excluded at the moment. Current regulatory approaches, like the Single-Use Plastics Directive, do not cover all relevant plastic-containing products that are discharged wholly or partially, and it is strongly targeted at private consumers, which is not sufficient. So the existing legal framework contains loopholes, and it needs a consistent implementation of existing regulations in the short term, but also revise and adapt the existing laws in the medium to longer term. And some kind of a wish or a recommendation is also that we need a coordinated, binding and comprehensive legal framework to reduce the plastic inputs into the environment that goes beyond the regulation of individual products and input pathways.
Thank you very much.